Human nature is to exist in an environment that is sustainable and suitable to live in. Homes have been around for thousands of years to cater for these needs and stayed that way for centuries. The quality of life is dependent on where and how you live, which has been becoming increasingly better in the recent years. The 21st century has been the best so far than any other time period combined, with the ever-increasing technological standards. Today, internet and television is in every home, and now the Internet of Things will be joining that. As smart homes become more popular, new technical challenges arise. Energy usage will become a major issue, so whatever it takes must be done to make smart homes environmentally friendly. To start off with saving energy, any energy that is left unused and wasted must be prevented where heat is notorious for this. A solution for it involves homes that do not require any active heating or cooling. The method involves using a quantum system to exploit the second law of thermodynamics to effectively reverse the arrow of time. In terms of quantum mechanics, temperature refers to the probability of the atom's nucleus being in a higher energy state. The second law of thermodynamics states how low entropy must always increase. This means that heat flows spontaneously from a hot body to a cold body and can be observed anywhere around us. The most important thing about this law is that it is irreversible. Irreversibility is a long-standing puzzle in physics. Not only does the phenomenon reverse the arrow of time, its initial state determines the arrow's final direction. Entropy production is often observed to be positive in nature, when the initial state is in low entropy. Standard thermodynamics assume that particles are uncorrelated before contact. The experiment used two initially correlated qubits prepared at different temperatures and were allowed to contact. The theory of the reversal of time was observed to be present, which establishes that the arrow of time is not an absolute but a relative concept that depends on the initial conditions. Sir Arthur Stanley Eddington developed the concept of the arrow of time, which can be determined by studying the organization of atoms, molecules, and particles. It is an unsolved general physics equation which could be drawn upon a four-dimensional relativistic map of the world. The second law of thermodynamics states which processes are allowed in nature, which only have a positive production of entropy. Ludwig Boltzmann put forward a microscopic resolution of the apparent paradox of irreversibility when he noted that initial conditions break the time reversal symmetry of the otherwise reversible dynamics. The experiment reverses the arrow of time to achieve this effect, which means that time machines may be a step closer. However, staying in the realm of reality, this discovery has many applications for mankind to use. The phenomenon transfers heat from a cold body to a hot body, which will make the cold body colder and the hot body hotter. We could see that this could be manipulated and applied to any method of thermal control, such as heating and cooling of a home. Coffee cups won't cool down, but instead will warm up depending on how you like your coffee, and if the technology becomes advanced enough, excess heat may be taken from the planet and transferred back to the sun. This will significantly change the way mankind will live. This phenomenon has only been recently discovered in November 2017 and has only just stopped being a theory. Articles of this investigation do not provide any applications for the research, and uses for it could only be come up as ideas based off the study. This means that the only concrete examples for this is the experimental setup used for the research. A solution of chloroform diluted in 99.9% deuterated acetone D6 was placed in a 500 MHz spectrometer utilizing a double resonance probe head equipped with a magnetic field gradient coil. The sample is diluted in such a way that the intermolecular interaction can be neglected to regard it as a set of identically prepared pairs of spin 1/2 systems. The superconducting magnet inside the magnetometer produces a strong intensity longitudinal static magnetic field to record measurements. In order for this to work, technology that utilizes this phenomenon must be more advanced than just correlating a handful of atoms. Trillions of atoms that are in the home must be correlated with trillions of atoms that are outside. They all should also come into contact and put back into place after heat transfer is complete. Numerical simulations of this experiment suggest that reversals may occur for a spin interacting with larger spin environments, thus stating that the phenomenon may occur in larger particles and molecules. In order to correlate these particles, the house must be fitted with special light bulbs that produce photons in an entangled state. One photon hits an inside particle and the other photon hits an outside particle. The correlation of the photons will be transferred to the particles. There is a possibility for particles other than the air to be correlated and could have a negative impact on people and objects since they are made up of atoms, hence further development of technology is needed.